Okay. So let's look at some examples here and talk about how we can describe the distribution of a categorical variable. And we already talked about it. How do you describe the distribution of a categorical variable? One of these three things here. Or just, just this right here, just list the percentages. The percentages tell us what values the variable took on and how frequently it took them on, right? So just list the percentages. That's how you describe a categorical distribution. 10 people were asked if they prefer hockey or football. Researchers then recorded the subject's gender and sports preference. The results are to the right. So I made this up because I just wanted nice, easy numbers and a small example to look at. So this is a data table. It shows every individual on the row and their responses to two variables in the columns. Numerically describe the distribution of sport preference for all subjects. For all subjects. So how would I could do counts. Let's see, football, 1, 2, 3, 4. 4 people like football, and there's 10 total, so 6 people like hockey. That's fine. You could describe it using numbers, percentages, I'm sorry. 40% like football, and 60% like hockey. So these would be two good answers. Okay, easy. Easy. It's much harder to describe distributions of numerical. It's a little harder to summarize. Create a frequency table. Well, that's kind of a ridiculous question. I need to get it out of the notes. So we got our sport, and we have our frequencies. Sports were hockey, and there were 6, and football, and there were 4. Yeah, sorry, these are stupid questions. Relative frequency table. Okay, now it gets hard. No, it doesn't. Hockey, football, 60%, 40%. Create a bar graph. All right, this is getting a little ridiculous. Football, hockey. So those are scales, and then label would be sport. Label and scale. Here I'm going to put frequency. 6, 3. So 4 people like football, and 6 people like hockey. This does not violate the area principle. Nice, simple graph showing that more people like hockey. Title, bar graph of sport preference. Create a bar graph for sport preference. Okay, this is okay. Two-way table. A two-way table of counts is a two-way table is a table that summarizes the data on the relationship between two categorical variables. So right here, I was just talking about sport preference, but we also recorded gender. So you might be interested in whether there's a relationship between gender and sport preference. That's what we're going to talk about here now. So a two-way table is a graph that displays basically the counts or percentages of those two variables. So let's go sport. We got football, hockey, and gender. We got male and female. So this kind of creates a little two-way table. So how many guys like football? 2 guys like football and 1 guy liked hockey. So of the guys, 2 like football and 1 like hockey. Of the girls, 2 like football and the remaining liked hockey. So 2 like football and 5 liked hockey. We could also put in some margins here, some totals. This is 3, 7 for a grand total of 10, and 4, 6 for a grand total of 10. So we call these the margins. In fact, we even use that to describe the distribution. Sometimes we'll talk about the marginal distribution. We mean simply the distribution in the margins. Okay. Okay, so let's talk about marginal frequency. So marginal frequency or marginal distribution. For some reason, kids really get confused by it. I don't know. I think it's because marginal is a kind of a silly word. I mean, when I say the marginal distribution, I'm talking about the distribution in this margin right here. Well, why do we call it a marginal distribution? It's just the distribution of gender. There are 3 boys and 7 girls. So the marginal distribution in this column for sports, for gender, is just the distribution of gender. And there's another marginal distribution. Here's another marginal distribution. That is the marginal distribution of sport preference. It's just percentage like football and hockey. It's exactly all the stuff that I graphed up here. But when you put it in a two-way table, we call it a marginal distribution. List the marginal relative frequencies of sport preference. So sport preference, 4 and 6. So for football, 4. Football. Okay, I don't know. 4 people out of 10 like football, that's 40%. And for hockey, 6 out of 10 liked hockey for 60%. Testing tip. This is a ridiculous AP testing tip. You got to show your work even if the percentages are really, really easy to calculate. So please don't just say 60%. Show what 2 numbers you divided to get 60%. Imagine this table had 5 columns here and 6 columns there and multiple variables, or not, well, 2 variables with many, many outputs. And your percentage is 23. Well, there might be several ways to get 23%. You need to show the grader that you're dividing the right numbers to show where you got your percentages. On the test, on my test, you must show your work or you will lose a point. Marginal frequencies of gender, that's just this one right here. So 3 girls, so female, 3 out of 10 for 30%. And for male, what am I doing? Those guys, 7 out of 10 for 70%, and there were only 3 guys for 30%. Okay. Conditional relative frequency. A conditional relative frequency gives a percent or proportion of individuals that have a specific value for one categorical variable among the individuals who share the same value for another. Again, that sounds very confusing, but if these are the marginal distributions, conditional distributions are like here. So this would be the distribution of sport preference for guys. So I'm conditioning on guys and I'm looking at sport preference. This would be the conditional distribution of sport preference for girls. Or I could go vertically. This would be the distribution of gender for people that like football. So you could kind of condition it whichever way you want. Okay. This question is saying list the conditional relative frequencies of sport preference for men. So this is the condition. This is the distribution I'm talking about. So that was the one I did this way. So 2 out of 3 like football. 2 people out of a total of 3 like football. 2 out of 3 for 67% like football. That remains the last person, or 33% like hockey. How about for women? Distribution of gender of sport preference only for women. So that women is a condition. Well, football was 2 out of 7, and hockey was 5 out of 7. 2 out of 7, I don't know what that is. %. 71%. Okay. So I guess what you should be thinking, or what I hope you're thinking here is, so 40%, excuse me. So 40% of all people liked football, 67% of guys like football, and only 29% of girls like football. So this should kind of give you a bit of an indication that perhaps there's a relationship between gender and sport preference. If there was no relationship, then I would have expected this to be 40% and this to also be 40%, but they were not, because guys seem to favor football and girls seem to favor hockey. Okay, we're going to talk about that. Right here, down here is an association or is a relationship, but let's talk about this graphical display of the two-way table. How do we make a graphical display of this information in a two-way table? Well, there's two graphs. I want to focus on the segmented bar graph because apparently they just seem to use it a lot in AP Stats, or they ask you to make these things in AP Stat on an exam. So side-by-side bars, you just have gender here, and then you have colored categories for side-by-side. So one variable is here, the other variable is like you're showing the distribution here off to the side, in bars side by side. Or you could look at percentages, and then this is the guys, and then you can kind of, it's basically like a little, it's a pie chart basically, right? Where 33% of them like foot males, 33% like hockey, and 67% like football. But for girls, 29% like football and 71% like hockey. So these are like little vertical pie charts, if you will. These will always go up to 100% because this is relative percentage, relative frequency, and I'm looking at all the categories, all the different variables that make up the guys, if you will. Okay. So if there's an association, there's an association if these percentages are different. The percentages match up exactly, then there should be no association or no relationship. So what is an association? We've talked about it now. Let's get a formal definition. There is an association between two variables if knowing the value of one variable helps us predict the value of the other. If knowing the value of the other variable does not help us to predict it, then we would say there is no association. Association is synonymous with relationship. And in all the classes, I kind of ask, what's another word that goes with these two? And a lot of times kids will say correlation. And I don't want to talk about this right now technically, but if you're going to use it, we need to talk about it. You can't use it in this context. Correlation only describes the relationship between two numerical variables. We are talking about gender and sport preference, so we should not talk about correlation. So you really got to be careful if you use the word correlation. In general, let's not use it now. In chapter 3, we'll talk more about it. But even if you want to talk about a relationship, you could just use these two words and not have to worry about using the bad word. But we want you to use this word, but we just want you to use it properly. So let's hold off on it and not use it yet.